Okay, in this video we're going to take a look at an ideal gas law problem. Obviously I'm telling you it's the ideal gas law, but you won't always get that information, perhaps not on a quiz or on a test. The only thing you're going to get is the question down below. So I'm going to start off by showing you how I know to use the ideal gas law, and then show you how to solve it from there on out. So this problem reads, how many moles? Those first three words are so critical. That word moles like jumps off the page and almost bites me. It's just clear as day that I'm going to have to use the ideal gas law because the combined gas law doesn't let me calculate moles. So moles is a key word here. So I'm going to box it in and label that as my unknown. N is going to be my unknown variable. Of oxygen will occupy a volume, there's my volume, 6 liters. I know that's volume because liters is always a unit of volume. And then 2.1 atmospheres. I know that's going to be my pressure because atmospheres is a unit of pressure. And then finally we're given a temperature here, 35 degrees Celsius. I'm not going to be able to use degrees Celsius, but I can make a simple conversion, convert it into Kelvin, and then plug it into the ideal gas law. So again, how did I know to use the ideal gas law? It was this key word moles. If any of these problems say anything about moles, you should immediately know you're going to have to use the ideal gas law. PV equals nRT. P is pressure, V is volume, N is number of moles, R is a gas law constant, I'll show you in a minute, and T is temperature. So let's go ahead and plug these variables in. Pressure, real simple, that was given to me in the problem. It was 2.1 atmospheres. Volume, real simple, that was given to me in the problem as 6 liters. We are looking for number of moles, that's my unknown, so I'm just going to leave it as N. And then R. R is a gas law constant. It's always the same number, 0.0821. And it has some kind of scary units. I understand these units that I'm about to put here will look scary, but if you just take it as a unit together, it's really not that bad. So liters times atmosphere divided by mole times Kelvin. Some students see this and they think this is a whole separate equation all on their own. It's not. It's just a unit. So the same way we have a number and a unit here, this is a number and a unit here as well. It looks kind of scary, it looks kind of crazy, I understand, but I'll show you how they cancel in just a minute. And then for your temperature, please do not make my favorite mistake. If you accidentally put 35 degrees Celsius here, please cross that out with a big fat X. Oh no, you must convert to Kelvin. So all I have to do is add 273, and you should end up with 308 Kelvin. Okay, beautiful. Now let's check our units, see if we're going to cancel out here. Atmospheres will cancel, liters will cancel, Kelvin will cancel, and I'm left with what unit? Oh, that's right, moles, because I'm trying to calculate moles. So, our units are all set. Now, how do I solve this? How do I isolate and get the variable n all on its own on one side of the equation? Takes a little bit of algebra, and I understand some of my students just don't like it. You're going to have to divide both sides by 0.0821. I'll be lazy and leave off my units. Times the 308. Again, being lazy here. That means everything else is going to cancel on the right-hand side of the equation. Whatever you do to one side of the equation, you must do to the other. So I'm going to divide both sides by 0.0821 times 308. Now, when you punch this in your calculator, there's a little bit of a catch to it. You have to remember to use parentheses down here in your denominator. Otherwise, your calculator wants to divide first when it needs to multiply first. So, let me walk you through how to punch this in your calculator. Punch in 2.1 times 6, hit your divide by key, hit open parentheses, 0.0821 times 308, close parentheses, and equals. That should get you a final answer of N is equal to somewhere about 0.5 moles. I'm pretty sure that I rounded for this answer. Your calculator probably spits out something like 0.49 something something, I'm not sure. So just depending on how you round, it should be about 0.5 moles. Again, the key piece to remember here is to remember to put parentheses in your calculator when you divide by that denominator. This has been a Rodriguez original production. I hope you enjoyed it. Go back, rewatch it, practice more example problems, study, and good luck.